Today we're finishing off object-oriented programming with some seemingly technical points about the object class and some of the things that you'll find there, but these are worth knowing because they really help you understand some of the weird errors you might come across when you're developing code. All right, so as we've mentioned several times before, every class in Java eventually inherits from the object class. Everything in Java is an object. True or false?
Yes.
Yes. A lot of confident yeses. Everything in Java is an object. Anyone doesn't think? You don't think everything in Java is an object? Primitives and not objects. Yes, okay, that's true. Yes, so there are the 8 primitive types, int, long, short, char, double, float. What else? Boolean. Yeah, so there are the 8 primitive types. I don't think I listed all 8. Those are not objects. Everything else in Java is an object of some kind. Just like in English, every real thing in the world is, in some sense, a thing. You can say thing and it covers every object in the world. Java, everything is an object except for the primitives. Java's messy like that. Some languages would not have this distinction between primitive types and reference types like Java does. Java is messy. Okay, but every time you create a new class, every time you start writing public class or even public enum, you're creating something that inherits from object. Object has a number of useful methods defined on it already. So every object already has these behaviors. Clone, you can create a complete copy of that object. That's not creating another reference to the object, it's creating a copy of that object. Equals, this method tells you if 2 objects are equivalent. And that's not the same thing as saying, are they the same object? It's saying, are they in some sense equivalent? And we'll look at how there's some important differences there, so we'll test that out in code. Finalize, this is a weird method that you probably won't ever have to implement, but if you do, it's worth knowing it exists. Finalize is a method that's called by the garbage collector just before reclaiming the memory for that object. So if for some object you've allocated some resources for it and you somehow need to clean them up before cleaning the memory for that object up, you can implement that there in the finalize method. Like I say, you'll probably never write a finalize method, at least in this course. It's only when you're starting to write more complex system level code that you might want to do that. Get class, we've used this a number of times already. The get class method returns you, in fact, an object that represents the class of this object. So when we're calling get class on any object, it's going to give us something that tells us what the runtime class of the object is. And we used that a number of times already when we wanted to find out the class of a thing that we created that was a dog. We found out when we called get class, it returned an object representing the dog class. Hash code. This is one we haven't covered yet, but you may have noticed whenever we print out an object, whenever we pass it to system.out.println and we print out an object that doesn't have a toString method defined, we see this interesting representation where we have the class name, the object, and then the @ symbol, and then a little bit of sort of garbled hex at the end. That garbled hex is coming from the hash code method, and we'll look today about how that's created. And finally, toString. We've used this a lot already, and we've overridden it a lot of times. ToString is meant to be used anytime you need a string representation of the object. So anytime you want to print it out to console or write it to a file or something like that. So every object has these 6 behaviors. So final classes and methods. If you make something final, it means you can't change it in Java. If you make a class final, it means that you cannot subclass it. So nobody is allowed to create another class which extends your class. Why might you want to do something like this? Okay, maybe a specific example. Thinking back to the animals that we did last lecture, which classes would be final in that case? So we had animals, we had mammals, and we had dogs and cats and snakes and reptiles. What kinds of classes should be final? A dog. Why should a dog be final? Not gonna create a new species that's like a subkind of dog. Yeah, that's possible. Although actually humans, I'm going to argue with you now. Humans do that all the time, right? We breed and we create subdogs. But yeah, that's the kind of idea. maybe a human shouldn't be, maybe a human should be final, right? You shouldn't try and create a new breed of human, or a new species out of humans. But okay, maybe that's again getting into genetic engineering and politics and stuff like that. All right, but so any class that you don't want anyone to be able to change, the behavior of this class is fixed, and you don't want people to be able to extend it and change it in some fundamental way, you can make it final. If you make a method final, very similar kind of idea, the method may not be overridden. So if you declare a class that isn't final, but it has a method that is final, nobody can override that method. So you can't create a subclass and override that method to change it somehow. You might want to do this if your method operates on the state in a very particular way, and you're conscious that if somebody operates on the state in a different way, implements this method differently, it may somehow break the contract of your class. So it may cause your class to behave in a way that was unintended. So by making it final, you ensure that nobody can do that the contract is fixed for all time. Abstract classes and methods. We did a little bit of this in last lecture already. Abstract is sort of the opposite of final. Whereas final says this is a concrete class and nobody can subclass this class, abstract says this is a purely abstract class and you must make a concrete class. You cannot instantiate my abstract class. You've first got to create a concrete subclass of this class before you can instantiate it. So it's sort of the flip side to final. And likewise, if you define a method abstract, it says that this method has no definition in the class in which I declared it. So you're going to have to define the method in a concrete subclass. You're going to have to provide a concrete implementation of that method in a subclass. So abstract and final are just two sides of the same coin. Mini quiz. Cool. I realize I didn't set up my phone to do this quickly. How quickly can I use the phone interface? So this will be O05. Okay, O5 should be open. Please check that you can answer that. So first of all, last lecture, when we were doing the animals, we did actually create a few abstract classes, but we didn't go back through, we didn't go through and make anything final. And we probably should do that. So, okay, before you said dog should be final. Okay, I agree. Let's not create any additional dogs. So we can mark dog final. And basically what that means, if we now try to create a new class, we'll call it super dog. No, wait. Awesome new dog? I don't know. Genetically engineered dog. How's that? Okay. So we created a genetically engineered dog and we're trying to extend dog. Okay, straight away, IntelliJ and the Java compiler is going to give us an error saying there's, oh wait, that's the wrong error. Okay. I want you to see the engineered dog. I want you to see the compile error. Okay, super. I think we had to give a dog a name. Okay. Now we get an error. Okay, IntelliJ, the Java compiler, is telling us cannot inherit from final comp1110.lectures.o04.dog. So we cannot extend our final class dog. We've limited dogs for all time. Okay, so genetically engineered dog is not a possibility the way we designed it. Okay, what else in the list of things here should be final, based on our criteria. Got a list of classes down the side here. Amphibians, animals. Kangaroos. Yep, they're pretty unique. Unlikely that we're going to want to genetically engineer some kangaroos, so okay. We're going to make kangaroos final. I'm declaring politically that humans should probably be final. Please don't try to breed a superhuman. What else? Snakes. So it's pretty much all of the things that are actually, okay, we decided that snake was a real animal. Okay. We could probably be more specific about snake. All of the things that are actual types of animals where you could go and say, give me a sloth, and someone could actually show you an example of that thing. Toad. So anything that's a real animal, elephant, as opposed to just an idea. So, okay, bird is really just an idea, right? It's a concept that we use as overarching to cover a whole lot of different kinds of animals. So you can't say that is just a bird. It's going to be some specific kind of bird, like a duck. And so for the specific kinds of birds, they should be final. Okay, so you're not always going to want to do this in your programs, but it's worth knowing that you have this ability to stop people subclassing your classes and changing the behavior in important ways. So, and you'll find a lot of interesting classes in the Java Standard ABI are defined as final for just this reason. The developers of Java don't want you going and changing the behavior of the Java Standard API, the Java Standard Library. Okay. All right, so we've made our classes final. I think I've got all the real animals in there. Let's look at the difference between equals in terms of object equivalence and the equals sign in terms of reference equivalence, because this is an important one and it catches people out all the time. So, okay, we're actually going to look at two things at once in this. So I'm going to call this class equals hashcode. But first we'll look at equals. PSBM, of course, create a main method. All right, say we have two strings, and it's going to be a little bit tricky to create this. Okay, so we're going to have a string A, has the value of the word same. I'm going to create another string B, but I'm going to do it in a slightly weird way. I'm going to actually type it in from the console, and I'll explain afterwards why I'm doing it this way. So we're going to create a scanner. As you know, if you create a scanner on system.in, you can read stuff in from the console. Okay. So we're going to read this string B in from, whoa, my computer is really lagging. We're going to read this in from the console. So we're going to use next line to read a string from the console. And now we want to test, are the strings the same? So we're going to print out two different things. We're going to print out, first of all, if A is equal to B using that equals operator. And then we're going to actually use the equals method on strings. We're going to say A dot equals B. Okay. So I'm going to run this code. All right, first of all, what if I type in a string on the console where it's a different string? It's not the word same, it's something else. What would you expect to happen? What will the program print out? Oh, I got to kill my genetically engineered dog over here in this package is causing trouble because it's not a real thing. It's trying to subclass a final class and it's causing a compile error, so I'm going to have to kill my genetically engineered dog. Sorry, goodbye. So, sorry, you were just about to say what you expected to happen. When I run that code and I type in a word, just a different word, what would we expect to see?
False.
False. False twice? Should print false for both of these, right?
Yes.
Okay, so let's run that. So I'm going to type in the word different. Okay, and yes, like we guessed, false and false. So the strings different and same are both not equal this way and not equal this way. Okay, what happens if I type in the word same?
False and then true.
False and then true. Okay, let's run that and see. So now I'm going to type in same. Okay, and like you said, false and then true. So why is this happening? It's because in this case, the string B that I read in from the console, while it has the exact same text, S-A-M-E, it's equivalent, it contains the same content as string A, which has the text S-A-M-E, but importantly, it's not the same object. It's a different string object containing the same text. And so when you're comparing them with this equals equals, you find that they're not the same. Sorry, that they're not equals equals. When you compare them with the equals method on string, you find that the strings are equivalent. So this is a different idea of equivalence in both cases.
So Josh, on that first print line, what is it saying? It's saying like same is equal to B, which is what is B when it's coming up false?
So you can imagine it that string A is stored somewhere in memory and it's got the text S-A-M-E. String B is stored somewhere else in memory and it's got the text S-A-M-E. Then it's comparing the references and saying, are they pointing to the same chunk of memory? In this case, nope, they're pointing to different bits, different things in memory. Therefore, they're not equals using the equals equals operator. Yeah. Whereas this method equals on string is going to go through and check each character in turn and make sure that the characters of the strings are the same. So it's going to go through both strings and compare one character at a time. Yeah. Okay. And you can do something very similar with objects. Okay. So, all right. Say we have, keep going back to person. We're going to create an inner nested static class, call it person. We always say that a person has a name. Got to give a type for the constructor parameter there. Okay, so we have a person class that has a name. If we try to create a new instance of a person, and okay, let's do this. So person, okay, so we're going to create a person called Jarwin. Who some of you will know as your tutor. And what class is Jarwin tutor? Okay. So who is the tutor for the class Wednesday 16B? Well, it's actually also a person called Jarwin. Okay. If we were to create two person objects like this and then compare them, so I'm just going to comment out the string stuff here so we don't need to run that. Okay, so let's compare Jarwin and the tutor for Wednesday 16B just the same way. And I'm going to use both the equals equals operator and the equals method. All right. So, given what I just told you about equals equals operator versus the equals method, what would you expect to see when I run this code? False true. Had a lot of false trues. Anyone think it'll be something different? False false. Why? Okay. So, why do you think it'll be false false?
I can't really articulate it.
Sorry, I missed the second part. Oh, did I get the names wrong? No, they've got the same name. Yeah, but
The first line is comparing references, and the second line is comparing their names.
yeah. Well, we've run the code. It returns false false. Okay, and so you're saying the first line compares the references, and okay, clearly these are different objects because we've used the new operator twice, so the references will be different. Yeah, but so why is equals also returning false in this case? Exactly. We didn't override equals, and in fact, we need to do this for any object class where we want to be able to test equivalence. We need to override equals. Okay, so let's do that. Let's override equals. Equals returns a boolean. It's called equals, of course, and it accepts an object So what the equals method does is just returns true if this object is equal to the object obj. Okay. So what are we going to need to do? We could be passing an object of any type at all into this method. Could be a string, could be array, could be hash table, who knows. So the first thing we're going to need to do is check the type of the thing that we got passed in. Okay, so how do we do that? Instance of, yeah, instance of person. Okay, so we only want to look at objects of type person. So if, in fact, if we're passed in an object that's not of type person, we can immediately say we're not equal to that thing. Because we know that Joan is person, so she can't be equivalent to a dog or a string or something else. So we'll just return false in the case where object is not a person. Okay, if object is a person, what do we need to check? What do we need to compare? We just need to compare the name in this case. So we can return this dot name dot equals name. Sorry. Oh, we're going to need the person's name, right? Okay, so we're going to need to cast object to a person. And we're going to need an extra set of parentheses there. And then get the name of that person. Okay, so we're comparing this person's name to the name of the person that was passed in. And if they're the same, then we say those two objects are equivalent. Okay, so now let's run that and see what we get. So remember, we're comparing Jiawen to the tutor for Wednesday 16B. Okay, so now happily we see false followed by true. So this true means that when we called the equals method, we're calling our overridden version of equals, we're comparing the names, and we find that, in fact, the tutor for Wednesday 16B and Jiawen both have the same name. So we're saying that they're the same person. Okay. There's one other thing we need to do when we override the equals method. There's an important, what we call a contract in Java, that whenever you override the equals method, you also have to override the hashcode method. And I'll just quickly demonstrate why that is. So I'll print out a couple of things. I'll print out the reference for both of those objects. Sorry, I'll print out both of those objects using the standard Java toString method, and I'll print out the hash code. So let's do that now. Jiawen.toString equals Jiawen.toString. So it's a little bit wordy, I'm sorry for that. I think it's useful to look at how toString is created from the hash codes. Okay, so we're going to print this out for both the Jiawen object and the tutor for Wednesday 16A, sorry, Wednesday 16B. So you'll see that these are different for those two objects. Okay, so we've run this, and what we can see is, okay, when we call toString on the Jiawen object, we get, first of all, the name of the class, then that @ symbol, and then this garbled bit of hex. And that bit of hex is actually a hex representation of the hash code. And so I printed out the hash code here on the side as well. So you can see, for both of these objects, we have different hash codes. Both the hash code and the toString representation look different for those objects. Okay, that's a bad thing, because when we've overridden equals to say that these two objects are equivalent, we should also override the hashcode method to return the same hash code for both objects. It's quite an important part of Java. You have to abide by this contract. So let's now override the hashcode method. So hashcode returns an int, doesn't need any parameters because it's operating entirely on this object. It's returning a representation just of this object. And how do you create a hash code? Well, the standard way of creating a hash code is to go through every important field of the object, and that's any field where you may look at it to compare for object equivalence against something else. and create a hash of that field and then somehow combine all of the hashes of those fields together. Now that sounds really complicated. In the case of this object, there's only one important field, and it's name. So the only important field here is name. So we can just return the hash code of the name. That's a nice simple way to implement hash code for this. All right, now what happens if we run the code again? Okay, the first thing you see is that the hash code, well, it's different for both objects. It's in fact a big negative number, but you'll notice that the objects now share the same hash code, so there's the same big negative number. And you'll notice that the objects now also have the same two-string representation. They've both got the same hex string after the @ there. So this is important. We've made the objects equivalent by overriding the equals method, and we also made them return the same hash code by overriding the hash code method. Okay, you've got to do both of those things at once. If you do one or the other, it can break all kinds of interesting things in Java collection classes and so on. All right, that may sound a little mysterious. If you're still finding it mysterious, the Oracle tutorials have a great section on equals and hash code and how they go together. So you could study that up at home if you want. But any questions at this point? Hash code makes perfect sense to everybody. Does everyone know what a hash code is? Okay. All right, I'll step back a little. So a hash code is just some compact representation of some data. So you can take any large amount of data and somehow squish it all together in a compact representation. But it has one important property, which is that if you make some small change to that data, the hash code will be changed by an arbitrarily large amount. So typically you might say you change one bit of the input data, half of the bits in the hash code are going to change. So it's not like the hash code of the word Tim is very close to the hash code for the word Tom. They're likely to be completely different, even though there's only one character difference. So hash codes take a huge amount of data and squish them into a compact format. In this case, in Java, that compact format is a single int. It's 32 bits. So for every single Java object, you can get an int hash code, one compact representation of all of the information in that object. There's a whole science to how you create good hashes and how you write a hash code method. Again, I probably don't really have time to go through it all here, but if this really interests you, start with the Oracle tutorials and then branch out from there.